recording this lesson, so in case anybody had to leave early or in case anybody arrived late, you could just look at the video. So one thing just kind of remember, whatever I go over today, your quiz may or may cover that. So you do kind of want to pay attention for that way for tomorrow quiz, you're able to do good on tomorrow quiz. Also, just to let you know, tomorrow quiz is quiz number 8. So just remember, any quiz passed now essentially is extra quiz. So say if the first 8 quiz you got 25 out of 25, then essentially you don't have to do the quizzes anymore because that will be your score for the quizzes. But if you have any back quizzes that you want to drop, essentially if you do better than the back quiz that you want to drop, then your new grade for quiz 9, 10, 11 will replace that quiz grade that you didn't do so hot in. So just know that pretty much past tomorrow quiz, essentially your quizzes should only go up. It shouldn't go down anymore because it's kind of impossible for it to go down. Because if you actually do worse than one of your worst quiz, then it will drop the worst quiz. So it will pretty much affect nothing. All right, and also just a reminder for test correction are due on Wednesday. So if you do have questions in regard to any of the test correction, you want to jump into, to my office hour, make sure to go to my office hour just to let you know some of the answer might be a little bit off, especially for the Tony Stark one and for the binomial problem about if you want to get at least 7 questions correct. The answer for those will be a little bit off. So if you do have question about that, jump into the office hour for that I can help you out with those. But just know for those 2, the answer are a little bit off, but for everything else should be fine. All right. Any question before we go on to chapter 9? Cool. All right, let's go to chapter 9. All right, so for chapter 9, we just have finished this problem. So it was a very basic problem. Like I gave you the X, I gave you the N, and I gave you the confidence level. But for today, what we're gonna go ahead and do, a problem where you have to find that information by yourself. So let's go ahead and get started. So for this one said, in July 2018, a university poll asked 1,783 registered voters nationwide whether they favor or oppose the death penalty for a person convicted of murder. 1,123 were in favor, attained a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for a person convicted of murder. Perfect. All right. So before we do A, B, C, D, any of those parts, first thing you want to do, you just kind of jot down some of the important information that they give you. Like one of the important information that they give you is your sample size. Sorry about that. So our sample size is 1,783. So that's one thing that they gave us. The other thing they tell us, of our sample size, how many people are in favor of the death penalty. So we're going to say X is equal to 1,123. So that's how many people are in favor of the death penalty. Lastly, the last important information they gave us that this is a 90% confidence interval. And if you remember the symbol that we use for confidence level is CL. C for confident, L for level, so confidence level. So this is a thing that you should be kind of jotting down. Any questions so far with any of these notation? All right, let's do A. So for A, it says check the condition to see if we could say the data is approximately normally distributed. So if you look at the original problem does not say if it's normal. So does not say if the data is normal. So if you look at the original passage, they don't tell us that the data set that we're sampling from is normal. So we had to check to see if it's approximately normal. So what do we know that help us check to see if something is approximately normal? What should I apply? Start with a C. End with a M. Cool, perfect, CLT. All right, so we want to check the CLT. So if you remember, for the CLT is three things. What we want to do, we want to check if it's a large sample. Oh, actually, it's two things. I was thinking about something else. We also have to check for big population. All right, so we have to check for the large sample size. So if you remember, the formula for large sample size is n times p hat times 1 minus p hat. That has to be greater than or equal to 10. And for big population, what we have to do is to check 20 times n, and this should be smaller than our population. And if you kind of remember the formula, well, not the formula, but the notation for population, it's capital N. So we want to check those two things. So let's go ahead and check them out. Any question for those two formulas? All right, so let's do N. So N, we already found it to be 1,783. Oops. 1,783. And we're gonna multiply this by p hat. In case you forgot how to find p hat is equal to x divided by n. So that means we get 1,123 divided by 1,783. So that's p hat. 1,123 divided by 1,783. And then we do 1 minus p hat, which is 1,123 divided by 1,783. All right. Any question with that so far? All right. So I'm going to go over to the TI-84, and I'm going to check to see what did that equal to. All right, so here's my TI-84. Let's turn it on. So we do 1,783. We multiply this. If you want, you can use parentheses, 1,123, all divided by 1,783. You close the parenthesis, open up a new parenthesis, you go 1 minus 1,123, if I remember correctly, divided by 1,783. You close the parenthesis, you press enter. Alrighty, so we get 415. All right, any question where the 415.7 comes from? All right, so let me go back to my notes. All right, so if you look at red, I put 415. So I put 415 is bigger than or equal to 10, which it is, because if you look at 415 compared to 10, 415 is bigger than 10. So we could say we have a large sample. So that's good. Now what we have to go ahead and do, we have to go ahead and see if we have a big population. So if you remember, for big population, you have to get 20 multiplied by n. So n in this case is 1,783. So I'm actually going to do that in my calculator. I'm not going to show you that because I'm pretty sure everybody could do 20 times 1,783. So you get 35,660. All right, so this should be bigger than your population. So if I look at my population, how would I describe my population? Like, who are we sampling from? Perfect. Registered voter. So kind of imagine how many registered voters do we have? Do you think there's more than 35,660 registered voter nationwide? Yes. Cool. Exclamation mark. Perfect. So our population is bigger than 20 times our sample size. Since our population is bigger than 20 times our sample size, we could say we have a big population, and I could go ahead and say our distribution is approximately normal. Since our distribution is approximately normal, I could go ahead and go on with this problem. But everybody good on checking the condition for approximately, to see if it's approximately normally distributed? Capital N is your population size. No, that's lowercase n, because if you kind of remember all the way back in chapter, well, I think it was chapter 3, whenever you use lowercase n means how big of a sample size you have. If you look at capital N represents how big of a population do you have. So capital N is your population size, lowercase n is your sample size. So you do kind of want to remember that. All right. Everybody good so far on A? All right, let's go ahead and do B. So for B, it says find the critical value for 90% confidence level. So if you remember critical value is this, Z alpha divided by 2. For this one, how would I find alpha? Let's see if we remember from, what was this, last week? How do I find alpha? Perfect, good. We're on it today. So in order to find alpha, alpha is equal to 1 minus confidence level. Our confidence level should always be in decimal. So if you look at, we have 90%. So instead of putting 90%, we're going to do 1 minus 0.90. And you get 0.10. All right. Everybody get how to get 0.10? All right. So up next, I'm going to do this. So we're going to say Z of 0.10 divided by 2. If I do 0.10 divided by 2, I get Z of 0.05. So in order for me to find Z of 0.05, what we're going to do, we're going to use our calculator, because this is where we use inverse norm. And you do inverse norm of 0.05. So the inverse norm of 0.05. And just for we could be somewhat accurate, you want to use whatever the inverse norm give you, just use 3 decimal places. So that way it can be fairly accurate. So I'm going to go over and you switch over to the TI-84. So that way you can see me enter inverse norm of 0.05. All right, so we go on. We go to second, we go to vars, we go to number 3, inverse norm. So if you look at my area is 0.05. If you look at mu, if you look at sigma, that's 0 and 1. All right, so we do enter. So if you look at this one, if I want to get 3 decimal places, you get 1.6448. So let me switch it over to my notes so that way you can see what I enter for the notes. All right. And just remember, anytime you're finding the critical value should always be positive. So no matter if the TI-84 tell you it's negative, you have to automatically know for this critical value, anytime you find the critical value, you always want the positive one. You always just switch over to positive. All right, so if you look at it, since we're gonna get 3 decimal places, these are my 3 decimal places. So you have to use the 8 to see if you should round up the 4 or leave it alone. So in this case, you round it up to 1.645. So Z alpha divided by 2 is equal to 1.645. Everybody good on the 1.645? All right. So let's do the point of estimate. So the point of estimate is P hat. So one thing I kind of want you to know, point of estimate is going to constantly be changing depending on the section that we're in. So right now, point of estimate is P hat because that's what we're using to estimate the population proportion or the parameter. But once we get to like 9.2, we're going to be using another point of estimate to estimate another parameter. So you kind of know point of estimate is constantly going to be changing depending on which parameter we're looking for. In this case, since we're looking for the parameter of population proportion, that's why we use P hat for the point of estimate. So the point of estimate in this case is X divided by N, where X in this case is 1,123, N is 1,783. So let me go ahead and just work this out. For this one, we're gonna get, let's get 4 decimal places. Just for we could be fairly accurate. So you get 0.6298. All right, so that's my Z value. Oh, sorry, that's my point of estimate. So now we're gonna do, sorry about that. Give me a minute. All right. So if you look at it, I already got my Z value, I already got my point of estimate. So the next thing to do for part D, I'm gonna get margin of error. So to get margin of error, if you remember the formula for margin of error, which I said is E, you're gonna get Z alpha divided by 2 multiplied by P hat times 1 minus P hat divided by N. Cool. So luckily we already found everything we need in order for the margin of error. Okay, if you look at for the Z alpha divided by 2, we found it to be 1.645. If you look at P hat, we found it to be 0.6298. And then you do 1 minus 0.6298, all divided by N, and N is 1,783. Right. Any question for D so far? All right, so I'm gonna go ahead and enter that into the calculator. So let me go to my TI-84. So we go 1.645. We're gonna multiply this by radical 0.6298. All right, so you do want to be careful for the next step because you want to use parentheses here. So you do parentheses, you do 1 minus 0.6298. You close parentheses and you divide it by N. So you do 1,783. You press enter. And we have our margin of error. So for margin of error, you get 4 decimal places, 0.018. All right, so if you look at our margin of error from the calculator, you give us 0.0188. And if you look at the last 8, right next to it is a 1. So we can round up that 8 because 1 is not bigger than or equal to 5. And that's it for our margin of error. Any question for the margin of error? All right. So up next, we're going to go ahead and we're going to construct the confidence interval. So let's switch it over. All right. So if you look at part E, it says construct a 90% confidence interval. So using this margin of error, we want to construct a confidence interval. So in order to do this, we're going to do P hat plus or minus my margin of error. So P hat is 0.6298 plus or minus 0.0188. So I'm going to go ahead and just work this out. So just remember for this one, there's 2 answers. You want to do 0.6298 minus 0.0188. And then you want to do 0.6298 plus 0.0188. So you're going to have 2 answers. Because remember, you're finding an interval. An interval is always a range of answers. So I'm going to go ahead and do this in my calculator. Hopefully you're able to subtract and add these values. Right. So if you do the first one, you get 0.611. If you do the positive value, you get 0.6486. And that's our confidence interval. And I'll show you how to double check your answer once we're all done with this problem. But that's pretty much the step that you kind of want to do whenever you're doing this. If I do ask you to do it, like find the z value, find the point of estimate, find the margin of error. Because all of these words, like if I ask you to find the margin of error, I do expect you to kind of know like how to find these. So that way, like I know you know how to find this formula. So if I ask you find the margin of error, like I do expect it to be able to do that. Yes, you always want to do the subtraction first. To kind of think about it, this number on the left should be smaller than this number on the right. Because if you do the addition first, then essentially you're gonna have the smaller number, or the bigger number to the left, and the smaller number to the right, which wouldn't really make sense. So you always want to do the subtraction first and then the positive. All right. All right. So based off of our sample telling us that the parameter could be 0.611 to 0.6486. So telling it should be somewhere in between here. So quick question, is this confidence interval, is it always going to be correct? Like, is it always going to give us the correct range? Cool. All right. So thanks, Raimundo. So if you look at it, it's not always going to be correct. Because if you kind of remember on Thursday, I know Thursday was a long, long time ago. If you remember on Thursday, we went over like the simulation of a confidence interval. So we went over like how many times it actually got it and how many times it was actually green. So the green outweigh the red, but you kind of know our confidence interval is not always going to capture the parameter. Sometimes it is, sometimes it's not, but for the most case it does. So let's do F. So for F, is it plausible that the true proportion for all registered voters who are in favor of the death penalty for those convicted of murder is 75%? So for this one, the key word here is plausible. So is it plausible that our confidence interval could be wrong? Is that plausible? Yeah, so it is plausible that the confidence interval could be wrong because you just kind of think about it, we're going based off of a sample. But if we're going based off of a wrong sample, the confidence interval might be wrong. So for this one, when it's asking, is it plausible that 75% of people are in favor of the death penalty? We'll say, yes, it is plausible since anything can happen. So I'll say, yes, it is plausible since anything can. So I would say, yes, it is plausible that our confidence interval is completely wrong, and it could be 75%. But let's do G now. So G said, based on your confidence interval, is it likely that the true proportion for all registered voters who are in favor of the death penalty for those convicted of murder is 75%? So for this one, part G, we want to go explicitly only using the confidence interval. So using the confidence interval, is it likely that 75% of people are in favor of the death penalty? Well, look at the confidence interval. The confidence interval telling us it could be anywhere from 61% to 64%. So from 61% to 64%, is 75% anywhere in between? No. So since 75% doesn't fall within the confidence interval, we'll say no, it's not likely. So we'll say no, it is not. So, and that'll be it. And we're done with this first problem of the day. Any question for that first problem? All right, so let me just show you how to quickly check your answer using your TI-84. So remember, for the TI-84, you only need three things. You need X, you need N, and you also need your confidence level. So let's go to the TI-84. All right, so we turn it on. So for this thing, you want to go to stats. You want to go to the test. And pretty much from chapter 9 all the way to chapter 14, you're going to be in the test area. So get used to being in the test area. So we want to go down where it says 1 prop Z interval. So I passed it. 1 prop Z interval. So we go X. X is 1,123. And N is 1,783. Confidence level is 90%, if I remember correctly. Yeah, 90%. You go ahead, calculate. So if you look at the answer that we got and the answer that the calculator giving us, we're pretty much spot on. So you can kind of see like how if you give me the answer in the and from the calculator, or if you give me the answer you do by hand, it should be essentially the same thing, even though we do have some rounding off error. All right, but that's it for this problem. So I show you how to do it by hand, and I show you how to use your calculator to double check your answer. Any question in regard to this problem? All right, so let's go on to the next problem. So if you look right here, it says a assembling line does a quality check by sampling 50 of its product and find that 16% of those 50 product are defective. Create a 80% confidence interval for the percent of defective product for the company and interpret this interval. So for this interval, we're gonna do it using the calculator. So we're gonna go ahead and just find N, X, and let's do the confidence level. Sorry about that. All right, so let's do the easy one. What's my sample size? Yeah, 50. What's my confidence level? Yeah, so 80. Yeah, for that one, you had to look over here. Cool. All right, up next, we're gonna go ahead and find our X value. So in this problem, do they give me my X value? Cool, good job, Clark. Yeah, so if you look at this problem, they don't give us our X value, but we could go ahead and find it. Because going back to P hat is equal to X divided by N. So if you're ever not given an X value, what you want to do, you want to just go ahead and say P hat times N is equal to X. So this is how you want to find the X value. So if you're ever not given an X value, that's how you find it. One quick little note, X should be a whole number. So X should always be a whole number because the thing is for your TI-84, if you give it X and you tell it X is not a whole number, it's not gonna really like that. It's gonna say syntax error and it's not gonna do the problem for you. So just know for X, it should always be a whole number and you just kind of want to use the rule of thumb. If the number next to the whole number is greater than or equal to 5, we're gonna round it up. If it's less than 5, we're gonna just round it down. All right. So for this one, what you want to go ahead and do, you want to do 0.16 times 50, and this come out to be a perfect 8. All right. So we found n is equal to 50, we found x is equal to 8, and we found confidence level, which is 80%. Everybody good so far with those 3 things? All right, everybody's happy. All right, so let's go ahead and go to the TI-84, and we're gonna work our magic. So we go to stats, we're gonna go to tests, we're gonna go to option A, there we go, option A. So for X, you put 8. So you have to kind of show you like how the calculator doesn't really like decimal. I'm gonna put 8.5 just to kind of show you that your calculator not really gonna like that. So we'll put n is equal to 50 and we'll put confidence level is equal to 80%. So if I go to calculate, it says quit and it says you have a domain error. So if you ever get that error, it's because you put x is equal to a decimal. So let's go ahead and let's go fix it now. So let's put 8. Cool. And if you look at it now, it gives us an answer. 0.093. And if you look at this answer, I'm going to round it to 4 decimal places. Like for confidence interval, for proportion, you should kind of get used to rounding it off to 4 decimal places. That's kind of like the more natural cutoff place, 4 decimal place. Okay, you want it to be fairly accurate. All right. Everybody good on how we get this answer, or did anybody get like a different answer than that? All right. Everybody's on their game. All right. So that's how you find the confidence interval. Up next, we're going to the interpretation. So usually for these interpretation, they usually have like a standard format of how it should sound. So I'm going to kind of give you the standard format, and then we'll do the confidence interval interpretation for this problem. So we'll say, we are yeah. Your blower something with the population. So usually it has this format. So it says we are confidence level percent. So right there, you just want to enter your confidence level. So you want to say we are, so in this case scenario, we will say we are 80% confident that the population, and pretty much where it says what's your population parameter, you put the population parameter that you're testing for. And then you put it between the lower bound, which this is my lower bound, and this is your upper bound. So pretty much we are stating like how confident we are in this method that the parameter, or sorry, that the lower bound, the upper bound and produce is correct. So let's do that for this problem. So we'll say, here, let's do a new color. Let's do blue. We'll say we are, so what should I put for my confidence level? Cool. So we'll say 80% confident that the population. All right. So what is my population like? What am I trying to figure out in this one? Like, and remember for this one, like the more, the better. You want to really describe what the population is. So what am I sampling from? All right, but remember, you don't want to. All right, cool, better. So we'll say we are 80% confident that uh, the population proportion of defective products. Uh, cool. So if you notice right here, population proportion, because we're doing proportional data sets, so you want to kind of add on that, so that the population proportion of defective product is between, and then you put the lower bound and the upper bound. If you want, you could put it as a percent. You could say it is between 9.36% and 22.64%. And we're all done for the interpretation. So just kind of know the basic layout for this interpretation. You always want to say we are a certain percentage confident that the population, and then describe what the population parameter is. So you want to describe that it's a proportion of defective product, and then put what it should be in between based off of this sample. All right, and we're all done for A. Any question for A? Sure. So let me show you the calculator once more. For that, you can see the lower bound and the upper bound. So pretty much you have to go to stats, you go to tests, you go to option A or one prop Z interval. So you might want to take notes on this, like, hey, I had to go to one prop Z interval to find this. And then put X is 8, N is 50, confidence level is 80. And let's go to calculate. And that's how you got the lower bound and the upper bound. All right.
Sorry. When I do that, it gives me an error. It just says error domain.
Yeah, so I actually explained that error domain a little bit earlier. So what you're doing, instead of putting X, you're putting 0.16, right?
No.
What are you putting for X?
I'm putting, I put 8 for X, and then 50 for N, and then 80 for CL, and I press calculate, and then it says error domain.
Try putting for confidence level, put 0.80.
Okay, yeah.
All
so
right,
I have to put 0.80?
Yeah, so I guess for your calculator, yeah. I've never seen a calculator.
Okay.
Yeah, so you put 0.80 versus doing the 80.
Okay, and that'll be for every problem, right? So I could get it right?
Yeah, for every problem, because apparently for your calculator, it doesn't like it when you put 80. You have to put out the decimal value.
Okay, got it. Thank you.
No problem. All right, so let's go to B. So for B, there is absolutely no calculation needed. All you have to do is you tell me what's going to happen to each one of these things. So for part B, say if we increase the confidence level to 90%, what will happen? Because remember, we did a confidence interval for 80%. So I want to ask what's going to happen if I change it from 80% to 90%. So if I go from 80% confidence level to 90% confidence level, what's going to happen to my alpha? Will my alpha go up or would it go down? All right, cool. So we got two people and they say down. Perfect. Yeah, so if we change it from 80% to 90%, your confidence level technically is going to go, well, sorry, your alpha is going to go down because remember, if you do 1 minus confidence level, it's essentially going to go down. What about for my point of estimate? What would happen to my point of estimate? Would it go up or down or stay the same? Cool. Stay the same. All right, well, what happened to my critical value? Would the critical value go up or would it go down? This is assuming the critical value is a positive number. So what will happen with my critical value? If I do a critical value for 80% and then switch it over to 90%, would it go up or would it go down? Yeah, so increase. So it will go up. What would happen to my margin of error? So will my margin of error go up? Would it go down or would it stay the same? Oof, tough crowd. All right, so it will increase. Good job. So we'll say go up. What would happen to the width of the confidence interval? Would the confidence interval get wider, or should it get narrower if I go from 80% to 90%? So would it get wider or would it get narrower? Well, for this one, did my confidence level go up or did it go down? It went up. So when we get more confident, are we more confident because we have a bigger range? Or are we more confident when we have a smaller range? So which one of these more? So if I have a basketball hoop and oh, that's horrible. So say we have two basketball hoops. So we'll say this is basketball hoop A. We'll say basketball hoop B. Which one am I more confident I can make the basketball in hoop A or hoop B? All right, hoop A. Why hoop A? Because it's bigger. So if I have two confidence intervals, which one would I be more confident in? The one with the wider width or the one with the more narrower width? Wider. So for this one, if I went from 80% confident to 90% confident, what would happen to my confidence interval? Would it become narrower or would it become wider? Yeah, so it should be wider. Cool. Yeah. So that's what happened. So, and also if you kind of remember the simulation we did on what Thursday, when we did the simulation, when we increased the confidence level and when we decreased the confidence level, like you can kind of see when we increased the confidence level, we got a wider interval. But when we decreased the confidence, when we decreased the confidence level, our interval became narrower. So you do kind of want to work on that because I do like asking like true or false question with these, and these are pretty nice to ask. All right. Any question in regards to the last part? All right. So what I want you to do next, I want you to try doing this next problem. So just find me the confidence interval, and for this one, you can use your calculator. So try practicing on that. And if you want me to double check your answer, just send me a private message and I'll double check your answer for you. I'll tell you great job or you need a little bit more work on it. So try doing this one. Yeah. So for the most case, everybody gave me the correct answer. So it should have been 0.0033 all the way to 0.0178. So yeah, so a lot of them really don't survive all the way to adulthood. All right, so that's your confidence interval. Any question in regard to that confidence interval? All right. So you should know how to do the confidence interval. The confidence interval not that bad. Like it is like a lot of little steps, but if you look at the steps, they're not that hard to do. All right. So let's go ahead and now we're gonna do the sample size. So up next, we're gonna go over how to determine like how big. So say if you're doing like an experiment and you want to figure out how big of a sample size should you have in order to get your experiment to be somewhat accurate. So depending on how accurate you want your experiment to be, you're either gonna want a big sample size or you're gonna want a small sample size. So what we have two different formulas. So this formula is for when we're trying to figure out how big of a sample size do we need. So here go formula A. And here go formula B. So if you look at the top of it, it has some criteria. So for one of them saying p hat is known. So this is saying if I know like a prior estimate of this population proportion, we could go ahead and use this first formula. So if you look at it, it says p hat times 1 minus p hat, and then you multiply by z alpha divided by 2, which is your critical value, and you divide it by e, which is your margin of error, and then you square it. So for this one, I'm going to tell you how big of a sample size you have, or how big of a sample size do you need in order to guarantee that you're going to have that margin of error. So for this n, you're always going to have a whole number. So that one should always be a whole number. And also for this one, you're always going to round it up. So for this one, you kind of got to go back when we did the classes for chapter 2 when we're doing histogram, where no matter what your class was, you always round it up to the next whole number. So the reason why we're always going to round it up to the next whole number, because if you actually round it down, you're going to lose precision and your margin of error is going to go up. So in order to guarantee that our margin of error stay at that or get a little bit smaller, what you always have to do, you always round up the value up to the next whole number. And I'll kind of show you when we do a problem. So the second formula, if you look at it, is when p hat is not known. So if p hat is not known, technically what we're doing, we're saying p hat is equal to 0.50. Because let's go back to this formula or this part of the formula where it said p hat times 1 minus p hat. If I replace p hat with 0.50, you get 0.50 times 1 minus 0.50. And if I do 0.50 times 1 minus 0.50, what would I get for our answer? So what's 0.50 times 1 minus 0.50? Cool. So you get 0.25. So that's where this 0.25 come from. It is saying if we don't know what p hat is, we're going to assume p hat is 0.50. So if we substitute 0.50 into the original equation, you get 0.50 times 1 minus 0.50, and that's where the 0.25 come from. Everybody good for the two formulas? All right, so let's do some example. All right, so for this one, so for the next poll of president approval rating, we want to get a margin of error of 4% with 80% confidence. How many individuals should we sample? All right, so they gave me a margin of error. So they tell me margin of error is 0.0 0.04. They gave me a confidence level of 80%. All right, so far so good with margin of error of 0.04 and confidence level 80%. All right, for this one, do they give me a p hat? Do I know what the p hat is? Perfect, thanks. So for p hat, it's a mystery to us. So if you look at the last sentence, it's saying how many individuals should we sample? So I know it's either gonna be this one or this one. So which one should I use? Should I use A formula or should I use B for the formula? You want to use B because for this one, they don't tell you the p hat. So we're going to use N is equal to 0.25 times Z alpha divided by 2 over E squared. All right, so I'm first going to go ahead and find Z alpha divided by 2 because that's where the confidence level is going to come into play. So we're going to first find alpha. Alpha is equal to 1 minus 0.80, which is 0.20. So now we want to find Z of 0.20 divided by 2. So you get Z of 0.10. So what I want to do in my calculator, I want to find Z of 0.10. So to find Z of 0.10, let's go to the calculator. So we're going to say Z of 0.10, which will be equal to second vars. We do inverse norm. And we change this to 0.10. So you need that 0 and 1. You press enter. All right. So we get Z is 1.282. Any question? I got Z is 1.282. All right. All right, so I already have everything I need for this formula. So you go 0.25 times Z, which Z is 1.282, all divided by E, which is 0.04, and you take this to the second power. So I'm gonna actually do that with my calculator, 1.282. Right, so you got 0.25 times 1.282 divided by 0.04. Want to make sure you take it to the second power. So you press enter. And if you look, you get 256.8. So 256.8. 256.8. So 256.8. So for this one, just remember you always round it up. So your final answer will be 257. So in order for me to have a margin of error of 4% with a confidence level of 80%, I have to have a sample size of at least 257. If I get more than 257, that means my margin of error will actually go down. But if I at least want to guarantee that I get a margin of error of 4% and an 80% confidence level, I at least need 257 sample size. All right. Any question in regard to this first problem? All right, so let's go ahead and do the second problem. So it says a baseball scout is trying to figure out how many times he should observe a certain shortstop at bat to get an accurate reading on what the true proportion of getting a hit will be in the major league. The scout wishes his estimate to be within a percentage point of the true proportion of getting a hit with a 99% confidence level. The baseball scout uses the 2018 proportion of getting a hit for all shortstop, which was 0.268. All right, so let's do the easy one. What's my confidence level? 99, perfect. So you got 99%. So for this one, what's my margin of error? And there's a keyword that kind of tell you this is the margin of error. All right. Margin of error is 0.08. So if it says within a percentage or 8%, that's telling me that's my margin of error, because it's telling me it could either be plus or minus that percentage. And if you remember, what do we do with the margin of error once we find it? We add it and we subtract it to the point of estimate. So that's why whenever they say within 8% or within a percentage, they're essentially giving you the margin of error. All right. So for this one, do they give me p hat? Like, do they tell me what the proportion of shortstop that get hit is? Yeah, they do tell me. So we get 0.268. All right. So before we go into the formula, we have to find what z alpha divided by 2 is. So to find alpha, you do 1 minus 0.99, which is 0.01. So we go z of 0.01 divided by 2. So 0.01 divided by 2 is z of 0.005. So what I want you to do, I want you to do inverse norm of 0.005 in your calculator. I'm going to do that on my calculator. And that way we can see if we match up. That's weird. All right, so if you do if you do inverse norm of 0.005, you get 2.576. Well, the 0.01 come from over here when we do 1 minus 0.99. All right. So let's go ahead and get the formula. So we do n is equal to p hat times 1 minus p hat times z alpha divided by 2, all divided by margin of error squared. So if you look at p hat is 0.268 times 1 minus 0.268 times z, which is 2.576, divided by margin of error, which margin of error is 0.08. And also don't forget to put the 2. So don't forget to put it to the second power. All right. Any questions so far on how I substituted into the formula? All right, so let me go to the TI-84 and let me enter that to the TI-84. So for the TI-84, you go 0.268 multiply, you want to use parenthesis, 1 minus 0.268, close parenthesis, open parenthesis, you put 2.576. You divide that by margin of error of 0.08. And you close the parenthesis. And lastly, you put it to the second power. If you do all of that, you get the following answer. So you get 203.4. All right. Any question on where does the 203.4 come from? So you do want to practice on entering this into your calculator, because that probably will be one of the hardest things for you to do. Because for this one, you do need parentheses, unless if you want, you can do 1 minus 0.26a. So that way you can calculate, it should be like 0.732 or something like that. And that way you don't have to use parentheses. But if you do want to just put it like this, you do want to use parentheses for it. All right, so up next, let's go back to the notes. All right, so if you look at my answer, I got the answer to be 203.4. But remember, we're finding n. We're trying to find out like how big of a sample size should they have, like if they're trying to observe this shortstop. So for this one, instead of putting 203.4, what we're gonna do, we're gonna round this 4 up, and we're gonna say that they should have 204 observations. So just remember, for these values, you always round them up to the next whole number, because if you actually round it down, you're gonna lose the margin of error. But any question for that last problem? Great. All right. So here go an extra example. So if you still need a little bit more help with it, you could try out these next two by yourself, and then you see if you could get these answers. But these are just for you practice wise. Cool. All right, so we're all done with 9.1. So we're gonna move on to 9.2. So 9.2, we're gonna still be doing confidence interval, but instead of doing this for the parameter of proportion, now we're gonna be switching over for the mean. So if you remember, the parameter or the notation for the population mean is mu. So what we're trying to do in 9.2, we're trying to estimate to see what the population mean is. So we're trying to estimate what mu is equal to. So for this one, we're never gonna have mu because we're trying to estimate mu. So in this section, let's see. So in this section, the point of estimate is X bar. So just remember in 9.1, when we talk about point of estimate, it was P hat. But now in 9.2, since we're trying to do a confidence interval for the population mean, instead of the point of estimate being P hat, now we're switching over that the point of estimate is X bar. Because now we don't know what the population mean is. So we have to use something that estimates the population mean. You can use P hat to estimate the population mean because they're not the same thing. So that way, in order for us to estimate what the population mean is, we use X bar. Right. Everybody good? That point of estimate is X bar. Great. All right, so we're going to skip over this because these are stuff that we essentially went over when we did our simulation. All right, so in this section, we're going to be doing confidence interval when sigma is unknown. So when sigma is unknown, we're going to use something called the t distribution or the student distribution. So for the t distribution, it's like the normal distribution, but we usually use it if we have a small sample size. Because essentially when somebody kind of noticed that like when you have a smaller sample size, with the smaller sample size, it really doesn't follow a normal distribution. It follows a different distribution, which is called the t distribution. All right, so for the t distribution, we're gonna have something called degrees of freedom. So degrees of freedom correspond to our sample size. So depending on how big or how small our sample size, our degrees of freedom are gonna kind of follow our sample size. So the formula for degrees of freedom is n-1. So in order to calculate what our degrees of freedom is, all you have to do, you do sample size minus 1. So if your sample size is 100, if you want to find the degrees of freedom for a sample size of 100, it will be equal to 100 minus 1, which is 99. All right. So let's go over some key things for the t distribution. So the t distribution is centered at 0, and it's symmetric about at 0. So the area under the t distribution is 100% or 1. And if I were to cut the t distribution in half, so if I were to cut the t distribution at 0, half of the data set would go to the left of 0, half of the data set will be bigger than 0. Also, as t increases or decreases without bound, the graph approaches but never equal to 0. So that is saying that it's never actually gonna stop. Like the t distribution could technically go all the way from negative infinity to positive infinity, and it would never equal to 0%. It will keep on getting closer and closer to 0%. And lastly, we'll go over this one. So as your sample size gets bigger and bigger and bigger, essentially the t-distribution is going to get closer and closer to the normal distribution. Because essentially what it's saying, once our sample size become big enough, and this is kind of going back to the law of large number and also the central limit theorem, as our sample size gets bigger and bigger, it going to get closer and closer to the normal distribution. Because if you remember for the central limit theorem, it said if your sample size is greater than or equal to 10, it should get closer and closer to approximately normal. So for the t-distribution, you're kind of going to notice once your value become closer to like 30, the t-distribution, the normal distribution are practically going to be the same. So to kind of illustrate that in a photo, we have this. So here we go, when we have a small degree of freedom, so when we have a small degree of freedom, but once we get a bigger degree of freedom, you should kind of see that the blue one is getting closer, because this one over here, this is the normal distribution. So as our sample size is getting bigger and bigger and bigger, it's getting closer and closer to that distribution, well, to the normal distribution. So let's go ahead and go to the formula. So if you look right here, here is our point of estimate. Point of estimate is equal to X bar. Our standard error is equal to S divided by square root of N. In order to find margin of error, in this case scenario, we're going to use T alpha divided by 2, and we're going to multiply that by standard error. And then in order to find the confidence interval, we're going to do point of estimate plus or minus the margin of error. So that's going to be the formula we're going to be using for this section. Any question in regard to this formula? And in order to find the T alpha divided by 2, S is your sample standard deviation. So we'll put it right there, S. So this is going back to chapter, what is it? We're going back to chapter 3. S is just sample standard deviation. All right, so right now we're gonna practice on how to find our T value. I don't know what you mean by critical point. Do you mean critical value? Okay, we are gonna be finding the critical value in a bit. Yeah, so we are gonna have critical value. So this is what we're essentially gonna go over right now. All right, so right now what I'm gonna go over is how to find T alpha divided by 2. So in order to find T alpha divided by 2, you're gonna need that T table that uploaded onto Canvas. Or if you have your book, I think you can use the one in the book. I think the one in the book is a little bit more complicated, but oh well. All right. So let's go ahead and do this one, or do the example. So for this one, we have N is equal to 16, confidence level is equal to equal to 95%. So for this, for number 1, what's my degree of freedom? Go 50. All right, so up next we're gonna go ahead and we're gonna find our T alpha divided by 2. So in order to find T alpha divided by 2, I'm gonna need 2 things. You're gonna need degree of freedom, and you're gonna need confidence level. That is nowhere close to it. So I'm gonna need those 2 things. So right now what I'm gonna do, I'm gonna transfer over from my notes, I'm gonna transfer over to the T distribution. Cool. All right. So this is a T table I posted up on canvas. So for this one, all you want to go ahead and do, well, let's go over this. If you look right here, it says DF. DF just stands for degrees of freedom. So what was our degrees of freedom? Oh, 15. So that means you select this row over here. So that's how you know which row you're going to select. You're going to use your degrees of freedom. Up next, what you want to go ahead and do is use your confidence level. So for this one, what was my confidence level? Go. So if you actually go on the bottom, you see how it says confidence level? And then if you look right here, you go 95%. So that means I'm going to select this column. So then if you look at where do they intersect? Wait. All right. So let me go back to my notes. All right, and that's how you find T alpha divided by 2. So for that one, all you have to do is look for the confidence level and look for degrees of freedom. All right, let's do number 2. So for number 2, what's my degrees of freedom if my sample size is 12? All right, 11. All right, so in our TI-80, in our T table, we're gonna look for this. We're gonna look for confidence level 80 and degrees of freedom of 11. So let's see, right? So degrees of freedom of 11, which is over here. And if you look at the bottom, we want 80%, which is over here. So if you look at where do they intercept at 1.363. So we got 1.363. All right, so that's our second confidence interval. Let's do our third, that's our critical value. Let's do our third critical value. So for this one, what is our degrees of freedom? Oh, one of those are correct, yes. So you should have gotten 20, because remember, you don't do n plus 1, you do n minus 1. So if you do 21 minus 1, you get 20. Well, it has everything to do with n, because the way you get degrees of freedom is with n. So saying it has nothing to do with n, it's kind of not right, because if you don't have n, you don't have degrees of freedom. Yeah, you do n minus 1. All right, so for this one, we have confidence level of 98%, and we have degrees of freedom of 20. So let's go ahead and do this. So 20 and 98, 20 and 98, 20 and 98, 20 and 98. So we have 20, which is over here. We have 98, which is over here. All right, so if you look at it, intersect at 20, well, not 20, but 2.528. So we'll put that into our. Cool. All right, last one. Let's do number 4. So for number 4, it says n is equal to 35, confidence level is equal to 60, degrees of freedom is equal to what? Yeah, 34. So let's go with 34 and confidence level of 60. So 34 and 60. So 34 and 60. All right. So if you look at 34, well, there is no 34. And this is kind of going back to pretty much once our sample size become bigger and bigger, it's getting closer and closer to Z. So if you kind of look at it, is like once you get to 30, start jumping by 10 and then by 20 and then by 20 and then by 900. So if you look at it, there is no 34, but you have to kind of look at it, which one is 34 closer to? Is 34 closer to 30 or is it closer to 40? 30. So we choose 30. And you go confidence level of 60%. So if you look at it, since 30 and 60% intersect there, our answer for that will be 0.854. 854, 854. All right, and that's it. So that's how you find your t value. So if you look at it, it's not that bad. But any question on how to find the t value? Mm. Well, how about this? I'll show you again on the next problem, because the next problem we have to find the t value again. So if you look at it, we get n is equal to 16. So what's my degrees of freedom if n is equal to 16? 15. So let's get t alpha divided by 2. So if you look at it, we want degrees of freedom of 50. Yes, yeah, that would be correct. So if you look at it, you have degrees of freedom of 15, you have confidence level 95. So, oop, no, not Kai, not Kai. All right, so if you look at this one, it's 95% confidence level. And for this one, what was our degrees of freedom? Wait, 15. So if you look at where do they intercept? They intercept at 2.131. So 2.131. Also, if you were paying attention, essentially we did number one again. Because if you look at number one had n is equal to 16. It had confidence level of 95%. So we did number one again. All right, so we get 2.131. Everybody good with 2.131 for t? All right, so up next, we're going to go ahead and find standard error. Or if you want, here, let's do margin of error. So margin of error, cool. So just remember, for if you ever have a case, so somebody has asked me, well, I'll go over that case after this. So we're gonna do margin of error. So margin of error, t alpha divided by 2 times radical n over s. So I'm gonna do t, which is 2.131 multiplied by s. S is 8 divided by square root of 16. So if I do 2.131 times 8 divided by square root of 16, let's see, what do we get? 2.131 times 8 divided by square root of 16. Let's see, what do we get for margin of error? So we should be able to do 2.131 times 8 divided by square root of 16. There you go. So you get 4.262. So that's my margin of error. So to find my confidence interval, we do x bar plus or minus margin of error. So we get 20 plus or minus 4.262. So let me go ahead and do that. So 20 minus 4.262 is 15.738. And then if you do positive, well, that should be a little bit easier. You should get 24.262. And that's how you get your confidence interval. So if you look at it, it's not that bad. All right. Any question in regard to how I found that confidence interval? All right, so there is a way to double check this answer on your calculator. So you do kind of want to follow along. So first, got to turn it on. Second, go to stats, go to tests, and you scroll down. And if you look right there, you see how it says Z interval. We actually want to get the one that says T interval. So you go to T interval. So if you look at it, it's asking, do you have the data or do you have the stats? In our case scenario, we have the stats. Data mean that you only have the number, but you don't have the mean or the standard deviation. So if you have the mean and standard deviation, you put stats. So you go right here where it says X bar we said is 20. If you look right here where it says S of X, that's standard deviation. So standard deviation is 8. If you look at N is 16. And your confidence level, if you look at this case scenario, is 95%. So you go to calculate. So if you look at it, you get 15.738 and you get standard and you get 24.263. So pretty much almost identical to what we got from our calculator or by doing it by hand. All right. But that's it for that example. Any question in regard to that example? All right, so let me go back to my notes. All right, so you should know how to do this by hand, and you should be able to double check your answer by using the calculator. All right, so I had a student ask me a question about the T distribution. So the question was, if N is equal to 36 and confidence level is equal, whatever, 90%. So 90% is over here. But if you look at our degrees of freedom in this case will be 35. Okay, if you do 36 minus 1, 36 minus 1 is 35. So if you look at 35, 35 is exactly in between 30 and 40. So anytime you have your degrees of freedom is in between two numbers, always go with the lower number. So in this case scenario, we'll go with 30. So you'll use 1.697. So if you ever get an occasion where it is exactly in the middle of 2 degrees of freedom, what you do, you just go with the lower of the 2 degrees of freedom, and that will be your answer. Any question in regard to that? Now, for that one, wouldn't be 40, because like I said, you go with the lower of the 2 values. Because if you look at 30, is that equally near to 40? So instead of using the lower number, you prefer to have the bigger number because that's going to give you a little bit more margin of error. So always go with the lower of the 2 degrees of freedom. So if it's between 30 and 40, you go with 30. If it's in between 40 and 60, you go with 40. All right. Any other questions? All right. So let's continue on with an example. All right. So for this process, for a simple random sample of 16 Honda Accord, the mean gas mileage was 23 mile per the gallon with a standard deviation of 7.5 mile per the gallon. It is known that the distribution of a 2005 Honda Accord is normally distributed. So that's important. So we already know the distribution of a Honda Accord is normally distributed, so we don't have to check the central limit theorem or anything like that. So let's look at part A. So part A said, what will be the best point of estimate for the population mean mile per the gallon for a 2005 Honda Accord? All right, so if I don't know what the population mean mile per the gallon for a 2005 Honda Accord, what will be the best estimate for it? Or what will be the best point of estimate for it? Well, anytime you don't know the mean population, what you want to do, you want to use the sample mean. So in this case, it tells us the sample mean mile per the gallon was 23. Cool. All right, and that's it. All right, let's go to part B. Part B says find the margin of error for a 95% confidence level and explain what it represents. All right, so we know confidence level is 95%. We know degrees of freedom. What's my degrees of freedom in this case scenario? 15. So we got confidence level 95%. We got degrees of freedom is 15. All right, so up here we're gonna find T alpha divided by 2. So I think we already did this one. It's right over here. So the T value is 2.131. So let's go ahead and find our margin of error. So for our margin of error, we're gonna say 2.131 multiplied by S. S in this case scenario, they tell us is 7.5. So you put 7.5 divided by square root of n. So you get square root of 16. Right. Any question? I got 2.131 times 7.5 divided by square root of 16. All right, so let me go ahead and do this. So we got 2.131 multiplied by 7.5, all divided by square root of 16. So you get 3.99, or we say 8. So that's your margin of error. So if you look at the problem, it says find the margin of error for a 95% confidence level and explain what it represents. So the margin of error, or the 3.998, represent how off we can be. So the 3.99 represent how off we can be. So it's saying like we don't have to be exactly correct, because this is how much wiggle room we have. So we have roughly 3.998 mile per the gallon that we could be off. So saying we don't have to be exactly correct, but the margin of error is telling you like this is how much wiggle room we're gonna be given. All right. Any question in regard to B? All right, let's do C. So for C, it's constructing 95% confidence interval for the mean gas mileage for a 2005 Honda Accord and interpret it. So right here, what we want to do, we want to get the point of estimate. And we want to add and subtract it to our margin of error. So our point of estimate, if we go back, they told us the mean mile per the gallon was 23. So we say 23 plus or minus our margin of error, which is 3.998. So I'm gonna say 23 minus 3.998, and you get 19.002. And if we add it, we get 26.998. Actually gonna minimize this because I didn't really give myself that much space to write anything afterward. All right, so that's your confidence interval. Any question on how we found this confidence interval? All right, so if you do read the problem, it says to interpret the confidence interval. So we want to interpret what the confidence interval is saying. So once again, we want to say we are, and you put what your confidence level is. So in this case, our confidence level was 95%. So we'll say we are 95% confident that the population mean mile per the gallon for a 2005 Honda is between, and then you put your interval. So you say 19.002 and 26.998. So if you look at this one, you want to say what's your confidence level? Our confidence level is 95%. You want to say what your population is. So we want to say the population is the mean mile per the gallon for a 2005 Honda. Oh, I think I forgot the Accord part. Let me put that in. So 2005 Honda Accord. And then you want to say what is it between. So it could be between 19 mile per the gallon all the way to roughly 27 mile per the gallon. So based off of this sample, we're saying that the confidence interval or the population mean could be anywhere between 19 mile per the gallon all the way to up to 27 mile per the gallon. All right, but that's it for C. Any question for C? All right, so let's do D. So D says, based on your confidence interval found in part C, is it likely that the mean gas mileage of a 2005 Honda Accord is 15? So for this one, should I say yes or should I say no? Cool. So you say no, since 15 does not fall in the interval of 19.002. All right, and that's it for that problem. Any question for that last problem? All right, so let's go to the next problem. All right, so up next we're gonna do this problem about baby first crawl. So it says the following data represent the age and week at which baby first crawled based on a survey of 12 mothers conducted by Essential Baby. So for this one, they tell us one of the baby crawled in 52 weeks, 30, 44, 35, 47, all the way to 28 weeks. So if you look at this one, the only thing they truly give us is our N. N is what? 12. Perfect. But if you look right here, this is what we call data. So they did give us the data. So with this data, we can actually find the mean and the standard deviation. So yes, no, since this is a sample, any information we get from this will be a sample mean and a sample standard deviation. So if you look at part A, they say use the information from the sample to give the best point of estimate of the mean age at which a baby first crawl. So for part A, we're gonna find X bar. If you look at part B, we're gonna find the standard deviation of the sample. So we're gonna find S. So we're gonna use our calculator in order to find that. So if you still remember chapter 3, that will be helpful to get this information. So first thing you want to do, go to stats, go to edit, and you want to edit this list and enter your data set. So we go 52, 30, 44, 35, 47, 37, 56, 26, 39, 26, 39, and 28. Cool. So first thing you want to do, enter all the data. So if I want to find the mean and the standard deviation, I go to stats, you go to calculate, and you do 1-bar stats. So frequency list should be 0 right here or left blank. And you go to calculate. All right, so if you look at my mean is 38.25. My sample standard deviation, which is S of X, is roughly 10. Cool. So we found mean is 38.25. And if you look, you want to use SX, which is equal to 10. So my mean is 38.25. Standard deviation of X is 10.001, which we're going to say is 10. All right. So we get X of bar is equal to 38.25. We get S is equal to 10. Any question for that? All right, so let's do C. So for C, it says constructing 95% confidence interval, estimate for the mean age at which a baby first crawl. So for this one, it says assume the data come from a normal distribution. So for this one, we're assuming it comes from a normal distribution. That means we don't have to check the central limit there. So for this one, I'm actually going to show you just how to do it with the calculator. So with the calculator, you go to stats, you go to tests, and we're going to go to the t-test. Remember, we still don't have that. So if you look at it, there's two options. You can either put data or you can put stats. Stats is when we're given the mean and when we're given the sample standard deviation. If you remember for this problem, we weren't given that information. So what we want to do, we want to select the data. Okay, what this is going to make the calculator do, instead of us having to find the mean and the sample standard deviation, the calculator will actually find that for you. All you have to do is enter your data set into one of the lists and then tell the calculator which list to use. So in my occasion, since I put my data set into L1, I'm going to tell the calculator to look at L1. I'm going to tell it the frequency is 1 because there's no frequency list. And then for the confidence level, I'm going to say is 95%. So then I'm going to go over here and calculate it. Cool. And that's our answer. So we get 31.896 and we get 44.604. And we're all done with that problem. So kind of notice if I give you the data, you want to use the calculator to your advantage and you want to tell the calculator, look at the data and find the confidence interval based off of that data. Right. Any question in regard to this last problem? All right, so I got a problem that I want you to try. All right, so I want you to take a minute and try and do that problem. Once you're done with that problem, give me the answer. So you can either put it in the chat or you can either private message me. And that way I could tell you if you got it correct. or if you still need a little bit of work on it. All right, so far we're 2 for 2. Unfortunately, we have more than 2 people in the class, so only 2 people getting it doesn't really count. All right, guys, so let's go over the answer for this one. So let me go ahead and work this out for you. For that way, if you got it right, well, you could kick back. But if you got it wrong, you kind of want to see why you got it wrong, because some of you might have chosen like the Z interval, which is the T interval. And the reason why we're using the T interval is because you don't know the population standard deviation. We only know the sample standard deviation. So you want to make sure you use the T interval. Make sure you put stats. So for the mean we should have said 1,230 for the mean. Sample standard deviation 270. And if you look at it for N we put 15. And lastly, you put 99% and you go to calculate. Cool. So that should be your final answer. So you do want to check what you put for the mean and the sample size and the sample standard deviation if you did get it correct, because you should be getting this answer. So if you look at it, this is a good way to always double check your answer. But if you look at it, this only gives you the final answer. So if I ask you to find like the margin of error, or if I ask you to find standard error, you should be able to find that by just doing the math, because the math shouldn't be that bad for that. So you should always double check your final answer with this, but just know, like, you should know how to find the mean and the, what is that? Well, not the mean, but the margin of error and stuff like that by hand. All right, everybody good with this last one? All right, so let's do this last topic and then we're done for today. So the last topic where we're going to go over is how to compute a sample size for the mean. So if you remember, we did this exact same thing, but we did it for proportional data set. We kind of figured out like, how big of a sample size do I need to get in order to have a certain margin of error and in order to have a certain confidence level. So we're going to do exactly the same thing, but now what we're doing is we're trying to estimate the population mean. So you kind of be careful with that. So for this formula, we're going to use Z alpha divided by 2 times our standard deviation of the sample divided by the margin of error. And lastly, you want to square the entire thing. So don't forget to square it, because that will completely change your answer. So let's do this first problem. So it says, suppose we wish to conduct a survey to see what the average students spend at the bar on a Saturday night. So if you look at it, we're interested in the average student spending. So we know from previous research that the standard deviation is $8. So we know S is equal to $8. And it says we want to see what is the minimum sample size. So if you look at minimum sample size needed to be 80% confident. So we want to be 80% confident. So that means our confidence level is 80%. And if you look right next to it, it says, and be within $2 of the mean. So we want to be $2 of the mean. Whenever they use the word within, they're talking about the margin of error. So we say E is $2. All right. Everybody go on S is equal to $8, confidence level is equal to 80, and E is equal to 2. Perfecto. All right. So up next, we're going to get Z alpha divided by 2. So if you remember Z alpha divided by 2, the first thing you want to do is find alpha. Alpha is equal to 1 minus confidence level. In this case, what's my confidence level? Cool. Stephanie already gave me the answer. So I'm going to guess that's a typo. So 1 minus 0.80, which is 0.20. So alpha is 0.20. So we're going to do Z of 0.20 divided by 2, which is equal to Z of 0.10. So in order to get this answer, we're going to do inverse norm of 0.20. So I'm going to go ahead and do inverse norm. Oops, sorry, typo. Not 0.20, 0.10. My bad. So we do inverse norm of 0.10. So inverse norm of 0.10. So you should get 1.282. Everybody good on 1.282? I'll go. All right, so up next, all you have to do is substitute n. So you go n is equal to z, which is 1.282, multiply by s, which s is 8. You divide by margin of error. Margin of error we said was dose, or 2. You square it. So let's go ahead and do this in our calculator. So we do parenthesis 1.282 multiplied by 8. Close, oops, don't want to close the parenthesis. You want to divide it by 2. And then you close the parenthesis and then take it to the second power. So you do that. All right. So if you look at that, you get 26.3. But same thing with the last one. If you remember for the sample side, we always round it to the next whole number. So since this is saying 26.296384, we round it up to the next whole number, which the next whole number will be what? Cool, 27. Cool. So that's mean in order for me to get a margin of error of $2 of the mean and have an 80% confidence level, I have to sample 27 students. So if I sample more than 27 students, my margin of error will actually go down. But if I sample at least 27 students, my margin of error will be $2 and my confidence level will be at 80%. All right. And that's it for that first problem. Any question for that first problem? All right, so let's do one more and then we'll call it a day. All right, so for this one said, the cheetah is the fastest land mammal and is highly specialized to run down prey. Researchers want to determine how fast the cheetah actually is. From prior studies, they were able to get that the standard deviation speed of a cheetah is 4.2 miles per hour. What is the minimum amount of cheetah they need to sample if the researcher want to be within 1.2 miles per hour of the cheetah actual speed and have a 99% confidence level? So they're giving us a bunch of stuff, so you kind of want to label all of this stuff out first. So we have 4.2, we have 1.2, and after we have 99%. So you might want to label the easiest one, which is the 99%, which is our confidence level. All right, what does the 4.2 represent? Cool, F. So that means 1.2 represent what? E. Yeah, and remember, because it say within is always telling you that's the margin of error, because we want it to be within 1.2. So they're telling us the margin of error has to be within that value. All right, so first thing we're gonna go ahead and do, we're gonna find alpha. So alpha is equal to 1 minus 0.99, which is 0.01. So now if I wanna find z of alpha divided by 2, you get z of 0.01 divided by 2, which is equal to z of 0.005. So in order to find z of 0.005, we do inverse norm. So we do inverse norm of 0.005. Cool. And let's see what does that give us. So I'm going to do the calculator. There you go. Second, bars. We do inverse norm. We do 0.005. You go enter, enter, enter. Press enter. All right. So we get z alpha divided by 2 is equal to 2.576. All right. So we get z is equal to 2.576. 2.576. Any question where the 2.576 come from? All right, so on to the fun stuff. Let's find n. So n is equal to s, or sorry, z. So 2.576 multiplied by s. S in this case scenario is 4.2. And you want to divide this by n, sorry, by margin of error, where margin of error is 1.2. And don't forget to square it. So if you do 2.576 multiplied by 4.2, 4.2, 4.2, divided by 1.2, and then if you take this to the second power, you get 81.29, which that doesn't even matter because we round this up to 82. So in order for me to get a margin of error of 1.2 mile per the hour, I have to sample at least 82 cheetah. If I sample more than 82 cheetah, I'll get a better margin of error. But this is the minimum amount of sample size I need in order to get a margin of error of at least 1.2. All right, and that's it for that last problem. Any question for that last problem? Great. All right, so I'm going to show you where test, well, not test, but quiz number 8 is going to be at. So let me see if I have that open. Should have it open. Cool. All right, so if you look at the week, we're actually in week number 6. So you want to go to the module for week number 6. All right, cool. So here you go, week number 6. So if you look right here, test 2 correction, which is due July 22nd. So for tomorrow quiz, you have to come here where it says quiz number 8. So for the quiz is gonna have 5 questions. It's gonna be 30 minutes. It's gonna cover essentially what we did today. So you go over your notes before you do the quiz. And it's gonna be open from 7 a.m. all the way to 7 p.m. tomorrow. So that way you should have enough time to be able to do the quiz. Like if you know the material, it shouldn't take you more than 5 minutes. If you don't know the material, like it'll take you more than 30 minutes. All right, but any question in regard to quiz number 8? All right, any question before I close out this lecture meeting? Cool. All right, so that's pretty much it for today. If you do have any question about anything we went over lecture or anything that test correction wise, you can always visit me in my office hour at 6:45 to 7:15 at that link. So if you do have any questions, just go to that link. For that way, I can help you out with any questions. But that's it for today. Have a good night. See you on Tuesday.